Good morning everyone. Today, one of my friends by name Sampada K A is here to give seminar on the topic logarithms. She is ambitious to get into one of the premier institute IIT. She aspires to be an engineer. Currently, she is taking JEE advanced coaching at VIDVATH. Heading over to her. Thank you.
Good morning everyone. Myself Sampada. I am from 2nd PU JEE Advanced. Today I am dealing with a concept called logarithms. I think you are not familiar with the concept because it was not present in your 10th board syllabus. Okay, let's begin the concept. I am not going with directly with the concept, but let's take some illustration then go with the concept. Tell me some number. Less than 10. Less than 10. Tell one number. 8. We know 8 square equals to 64. Yes, no? And another number. 3 cube equals to 27. What logarithm says about it? This is in the expression a power x equals to b. It is an exponential form. It is in exponential form. A is the base of this expression and b is the argument. And x is the exponent or part, what you call. Here 8 is the base and 2 is the exponent. Logarithm says that log of b to the base a is equals to x. This x is the exponent is called as log of b to the base a is known as log. Logarithm we find difficult to write every time logarithm. So we write in short form log. Apply log to this expression. Log of 64 to the base 8 is equals to 2. Got it? Understand? Yes. This one. Apply logarithm to this. Tell. Log of to the base is equals to. Got it? Then go with the definition. What logarithm definition says? Logarithm is a number. We can obtain this number by raising the base to the some exponent to get the number. Here we are raising the 8 to the base to the exponent 2 to get the 64. 2 power 2 is equals to 4. In order to get this 4, we are raising the 2 to the power 2. We get 4. This 4 is the log of 4. Log of 4 is to the base 2 is equals to 2. Understand the definition of the logarithm? Then this base here, this a, I will write first. Okay, log b to the base a is equals to x. This base a should not equals to 1 and also should not equals to 0 and it has to be positive. Why this is? If the logarithm of negative numbers, take 1 power x, 1 to the power any, 1 to the power any is equals to 1. It is a constant. If we take log of any power to the base 1 is always a 1 because apply logarithm to this. the base is always x. If we take any number to the power, it always be 1. So we should not use log of base as 1. And 0, 0 to the power any is always a 0. Apply logarithm to this. So we should not use this 0. And why should not we use negative? Anyone has an idea about complex numbers? Complex numbers. Tell, what is complex number? Huh?
All the numbers are complex.
Okay, I will tell.
Integers, whole numbers, all included.
I will tell. What is this? It is denoted as I. If we take minus 1 to the power x equals to something a, apply logarithm to this. It is a complex number. If we take x as 1 by 2, minus 1 root of x, root is equal to x. This is a complex number. The complex numbers are not defined in the logarithm. It are out of the boundary of the logarithms. So we should not use negative numbers in the logarithms. Okay? Next, graph of logarithm. Anyone had an idea about domain and range? Domains are the set of values of in a graph. This is x plane and this is y plane. Domains are the set of values of x. The numbers which are present on the x plane, it is called as domain. And range. The numbers which are present in the y plane are called as range of the graph. What logarithm says about that? Log of b to the base a is equals to x. A should not equals to and always yes. First take the case a greater than 0. It is the first case of the logarithmic graph. And one thing, I think you all learned in the 10th this expression. Yes or no? Let a be the any number. Any number to the power 0 is always 1. Apply logarithm to this. 2 power 0, 100 power 0, 1000 power 0. Apply logarithm to this. Visible? Log of 1. Apply logarithm to this. In general, we can say that a power 0 equals to 1. Log of 1 to the base a is always a 0. Log of 1 to the any base, a being any positive number is always a 0. Okay? Get it or have any doubt? Okay, let's come to the graph. Log of 1 to the base a is always 0. So 0. Logarithm graph for the condition a greater than 0 come like this. It is an increasing graph. The log of these numbers are very close to the 0, but never be the 0. Log never be defined for negative numbers 0 or 1. So log of 1, the graph always passes through this point. Log of 1 is, and a should not equals to, and okay. Next case, a is in between 1 and 0. A should less than 1 and a should be greater than 0. The graph will look like this. 1, 2, and 3. In between, the nature of the graph in between 0 and 1 is always a decreasing function. It is an increase. The graph go like this. But here, log of 1 it also passes through this point. But it is a decreasing graph. Okay, got it? In the case of 0 to 1, it's always an, in case of greater than 0, okay. Let's move on to next topic.